The Natural Difference Vegetation Index reveals much information of what's going on underground in ways that we might not think. Now, as we know, this index really highlights vegetation, and it does this by emphasizing areas of high infrared, near infrared reflection and low red reflection. And plants do this because they're trying to absorb as much energy as they can without becoming overheated from the near infrared rays. It also distinguishes bare ground, especially like non-moist bare ground, because bare ground reflects both infrared and red. So those two areas are very distinct from each other. And another area that's very distinct is soil that has a lot of moisture. So areas of soil with moisture and areas of high dense vegetation are good indicators of underground water bodies. Another area that is very helpful in determining underground water bodies is lineaments. Lineaments are faults or fractures that run through the rock underground. And it's through these areas that water flows. And there are very distinct drainage patterns amongst lineaments that can indicate if water is pooling or if water is getting collected or networking. And these are the types of patterns that would be analyzed to find probable zones. There's other hydrological data that is used in the form of boreholes. And you would probably first do some analysis and make some predictions on where you would think that water would be. And you would draw boreholes to verify what you've already, predicted. And it gives you more insight into the underground world. DEM model is also very helpful, even though it is just surface elevation. Understanding the general flow of water over surface can make you give you some prediction of what might be happening underground, because often there is some sort of parallelism between the two. And once you have made all your layers and found multiple probable zones, you would weight these zones and you would form a raster. It would be a grid raster, and each pixel would calculate a probability of water based on all the probabilities of your other layers. And depending on the source of the data or the validity of the data, you would have a higher or lower weighting rank. And you would produce one raster file that would have your highest probability zoned water. And that's how GIS and remote sensing can discover probable underground water zones, as a very brief overview. So I'd like to thank you for taking the time to look at this presentation. If you have any questions, you can ask me in the comments and tell me what you think about this medium. I can't wait to view all of your presentations, and the class has been quite the pleasure. Have a good one. Bye-bye.